You know, I've been thinking about what I should tell you today, and I realized what you probably want to hear about is quantum mechanics, or relativity, or some fancy physics that sounds impressive at parties, but I'm not going to talk about any of that. Instead, I want to talk about something more fundamental, something that matters whether you're doing physics, or fixing a car, or just trying to figure out why your life isn't working the way you thought it would. I want to talk about how to think. Not what to think, how to think. Because here's the thing I've noticed. Most people don't actually think. They go through the motions. They use the right words. They follow the procedures. They get the answers. But something's missing. The real thing, the actual understanding, isn't there. Let me show you what I mean. Suppose I ask you, what is energy? Go ahead, think about it for a second. What is energy? Most people will say something like, energy is the capacity to do work. Perfect. Textbook answer. You probably got an A on that test. But do you know what that means? I mean, really know? Can you close your eyes and see energy? Can you feel it when you look at a moving car or a hot stove or your own body walking upstairs? Do you see energy moving around? Or have you just memorized a phrase that makes you sound like you know what energy is? See, this is the problem. We confuse memorizing definitions with understanding things. And I'm guilty of this too. I catch myself all the time doing it. I'll be talking to someone and I realize I'm just reciting words I learned somewhere, but I don't actually understand what I'm saying. It's embarrassing when you catch yourself doing that. So the first thing, and this is crucial, the absolute first thing you need to do when you're trying to solve a problem or understand something is to be honest, brutally, painfully honest with yourself about what you actually know versus what you just think you know. This is harder than it sounds, because admitting you don't understand something feels bad. We're trained from childhood to have answers. The kid who raises their hand and says, "I don't know," doesn't get praised. The student who admits confusion doesn't get the A, so we learn to fake it. We learn to sound smart even when we're completely lost. But here's the secret. Real intelligence doesn't start with knowing. It starts with not knowing. It starts with looking at something and saying, "I don't get this. I really don't get this. And I'm going to admit that to myself so I can actually start learning." Let me give you an example from my own work. When I was first learning quantum mechanics, everyone was using this mathematical machinery operators, wave functions, all this formal apparatus, and I could follow the math. I could do the calculations. I could get the right answers on exams, but I didn't understand what was happening. And for a while, I pretended I did, because everyone else seemed to understand it. The professors were confident. The textbooks were authoritative. Surely I was just missing something obvious, right? But then I stopped. And I asked myself honestly, do I actually see what's going on here? Or am I just pushing symbols around on paper? The answer was painful. I was just pushing symbols. I had no idea what the symbols meant. No physical intuition, no picture in my head of what was really happening. And that admission, that honest, I don't know, that's when I could finally start to understand. Because now I wasn't defending a false sense of knowledge. I was actually curious. Actually seeking, actually thinking. Now here's where it gets interesting. Once you admit you don't understand something, what do? Well, there's the standard approach. You go read the textbook, you listen to the lecture, you follow the established method. And sometimes that works. But sometimes, often, actually, the standard approach is exactly what's keeping you from understanding. Let me show you what I mean. Suppose you're trying to understand why ice floats. The textbook will tell you about crystalline structure and density and hydrogen bonding. All true, all correct. But do you actually understand it now? So here's what I do instead. I attack the problem wrong, deliberately wrong. I come at it from an angle that probably won't work, just to see what happens. I might ask, what if ice didn't float? What would that mean? Okay, then when water froze in a lake, the ice would sink to the bottom, and more water would freeze on top and sink. And eventually the whole lake would be solid ice. Fish would die. Life in cold climates would be completely different. So there must be something special about water that makes ice float. What is it? Or I might try to picture the molecules, not read about them, but actually picture them in my head. Water molecules in liquid moving around, bumping into each other, kind of crowded. Now they freeze. What has to happen? They must arrange themselves in some pattern. What kind of pattern would take up more space than just being randomly crowded? Oh, maybe they link up in a way that creates gaps, like people holding hands in a circle versus standing in a crowded elevator. See what I'm doing? I'm not following the proper method. I'm playing with the idea, approaching it from weird angles, being wrong a bunch of times, building intuition. And this is crucial. You have to be willing to be wrong, not just once, but over and over. You try something, it doesn't work. You learn something from the failure, you try something else. Most people are terrified of being wrong. They want to go straight to being right. So they memorize the right answer without ever developing the intuition that makes the right answer obvious. But I'm not afraid of being wrong temporarily. Being wrong is how you explore the space of possibilities. Being wrong is how you develop physical intuition. Being wrong and then correcting yourself is how you actually learn. You know, there's something else I should mention. When you're solving a real problem, not a textbook exercise, but a real problem, you often don't even know if you're wrong or right. You're in this fog of uncertainty, and that's okay. That's normal. The mistake people make is they try to get rid of the uncertainty too fast. They reach for an answer, any answer, just to escape the discomfort of not knowing. But I've learned to be comfortable in that uncertainty, to sit with it, to explore it, to use it. Because when you're uncertain, you're actually thinking. When you're certain too quickly, he probably just grabbed onto some memorized answer without checking whether it really applies. Okay, so you've admitted you don't know something. You've attacked it from unconventional angles. You've been wrong a few times and learned from it. Now what? Now you test it against reality. This is the part people forget. They get so caught up in their theories, their models, their beautiful equations, that they forget to check whether any of it actually matches what happens in the world. Nature doesn't care about your theory. Nature just does what nature does. And if your theory doesn't match nature, your theory is wrong. Doesn't matter how elegant it is. Doesn't matter who taught it to you. Doesn't matter how many people believe it. Wrong is wrong. Let me tell you about something that happened during the investigation of the Challenger disaster. You know, the space shuttle that exploded. I was on the commission investigating what happened, and everyone had these complex theories, very sophisticated. Lots of computer models and engineering analyses. But I wanted to see something simple. I wanted to know what happens to those rubber O-rings in the cold. So I got a piece of the O-ring material. And during one of these official hearings, with all these important people around, I took the O-ring and I put it in ice water. Then I squeezed it with a clamp. And we waited. And when I released the clamp, the O-ring didn't spring back. It stayed compressed. That was it. That was the answer. The shuttle launched on a cold morning. The O-rings were stiff from the cold. They didn't seal properly. Hot gases escaped. Disaster. One simple test. Reality gave me the answer. And you can do this with anything. Anything you're trying to understand. Find a way to test it against what actually happens. Not against what other people say happens. Not against what other people say happens. Not against what seems logical. Against reality itself. This connects to something really important, something I call cargo cult science, but it applies to all kinds of thinking. You know the story of the cargo cults? After World War II, in some Pacific islands, the people had seen planes land with cargo. When the war ended and the planes stopped coming, they built mock runways. They made headphones out of wood. They waved landing signals. They had the form of an airport, but not the substance. And of course, the planes didn't come. In science and in thinking generally, people do this all the time. They have the form of understanding without the substance. They use the right vocabulary. They follow the procedures. They write things in mathematical notation. They cite authorities, but they're not actually thinking. They're performing a ritual that looks like thinking. And the way you tell the difference is this test. Can you explain it simply, in plain language, without jargon? If you really understand something, you can explain it to a child, not by lying to the child or oversimplifying to the point of being wrong, but by finding the simple truth underneath all the formal complexity. The complexity is in our descriptions, our mathematics, our formalism. But the underlying reality is usually pretty straightforward once you actually see it. So whenever I think I understand something, I test myself. I try to explain it in the simplest possible way. And if I can't, if I have to hide behind jargon, if I have to say it's complicated, if I have to use fancy words to cover up gaps in my understanding, then I know I don't really get it yet. This is humbling. You find out that most of what you thought you knew, you don't actually know. But it's also liberating, because now you can actually learn it. Now you're not trapped in fake knowledge. You know, I'm realizing as I talk about this that what I'm really describing is a kind of algorithm, a method, not a rigid procedure, but a way of approaching problems that works over and over. Let me see if I can make it explicit. First, be honest about what you don't know. Don't pretend. Don't fake it. Look at the problem and admit where you're confused. Second, attack from unconventional angles. Don't just follow the standard method. Try weird things. Be willing to be wrong. Play with ideas. Build intuition. Third, test against reality. Always. Your idea might sound good, but does it match what actually happens? Find a way to check. Fourth, explain it simply. If you can't explain it in plain language, you don't understand it. Keep working until you can. But there's something else, something that ties all of this together. It's curiosity, real curiosity. Not the kind where you want to know the answer so you can show off, but genuine wonder, genuine desire to understand how things work. I think this might be the most important part. Because if you're genuinely curious, all the other stuff follows naturally. You'll admit when you don't know things because you want to know them. You'll try unconventional approaches because you're excited to explore. You'll test against reality because you actually care whether you're right. You'll work to understand simply because you want to really see it. Without curiosity, all of this is just a chore, a series of steps you force yourself through. But with curiosity, it's a joy, it's fun, it's what you want to be doing. And here's something interesting. Curiosity is a choice. You can choose to be curious about things. You can cultivate it, nurture it. Most people lose their curiosity somewhere along the way. They stop asking why, they stop wondering how things work. They accept explanations without checking them. They stop caring about understanding and start caring about other things, grades, status, looking smart. But you can get it back right now, just by deciding to actually care about understanding something, not performing understanding, not faking understanding, actually genuinely understanding. Pick something, anything, something you encounter in your daily life, and instead of just accepting it, get curious about it. How does it work? Why does it work that way? What would happen if it was different? And then use the method. Admit what you don't know. Attack it from weird angles. Test it against reality. Explain it simply. Let me give you a challenge. Right now, think of something you believe you understand. Maybe it's from physics. Maybe it's from your job. Maybe it's just how something in your house works. Now try to explain it to me, out loud if you're brave, or just in your head. Explain it in the simplest possible language, like you're talking to someone who knows nothing about it. Can you do it? Really? If you can, wonderful. You actually understand it. If you can't, if you're stumbling over words, if you're reaching for jargon, if you realize you're just repeating things you've heard without really knowing what they mean, then congratulations, you just discovered something valuable. You've discovered the difference between fake knowledge and real knowledge, between memorized answers and genuine understanding. And now you can fix it. Now you can go actually learn the thing. Now you can move from performing knowledge to possessing it. You know, I think this might be the most important thing I can teach you. Not physics. Not mathematics, this. The ability to be honest with yourself about what you understand and what you don't. The courage to attack problems from unconventional directions. The discipline to test everything against reality. The clarity to explain things simply. This is how you think. This is how you solve real problems. This is how you avoid fooling yourself. And fooling yourself, that's the easiest thing in the world to do. You are the easiest person to fool. Your brain wants to believe it understands things. It wants to feel smart. It wants to avoid the discomfort of uncertainty. So you have to be vigilant. You have to keep checking yourself. Keep asking, do I really understand this? Or am I just comfortable with the words? Let me put this all together for you. Here's the method 1. Start with honest ignorance. Admit what you don't know. 2. Play with ideas. Attack from weird angles. Be wrong repeatedly until you're right. 3. Test everything against reality. Nature is the final judge. 4. Explain simply. Simplicity is the proof of understanding. 5. Stay curious. Genuinely, honestly curious. That's it. That's the algorithm for thinking. It's not complicated. It's not mysterious. It's just honest, playful, reality-based thinking. And you can start using it right now, today, this minute. The question is, will you? Will you be honest about what you don't know? Or will you keep pretending? Will you explore ideas playfully? Or will you rigidly follow standard methods? Will you test against reality? Or will you accept comfortable theories? Will you work to understand simply? Or will you hide behind complexity? Will you stay curious? Or will you settle for the appearance of knowledge? These aren't easy choices. The path I'm describing, the path of genuine understanding, it's harder than just memorizing answers. It's harder than just following procedures. It's harder than just sounding smart. But it's real, and it's powerful, and it's the only way to actually understand things, instead of just pretending to. So go. Think honestly. Play curiously. Test ruthlessly. Explain simply. That's how you learn. That's how you solve problems. That's how you think. Everything else is just noise.